Hi everyone, welcome to AI Crack channel. This is Akash Kangwar and today we'll be studying AOD lecture 1. AOD is actually one of the most important topics in terms of PGDBA and I would suggest everyone to focus more and practice more AOD. This is question of the day 22 and let's begin. Now it is kind of obvious that we would be studying certain applications of derivatives in this lecture. So the first application would be derivative as a measure of rate. Now what is rate? Rate is nothing but we want to measure a change with respect to certain variable and most of the time it's time only, right? So let's say speed. What we do over speed, let's say we are covering distance x and we are moving with certain speed v. So what is v? V is nothing but the change of x, how x is increasing with respect to time. So this is how we calculate the speed. Let's say there is one container over here and there is a hole over here and water is coming out of it. Now we want to find out how much volume is coming out per second or maybe per microsecond. That is how we are using this rate. That is how rate is being defined, right? And we'll see the application of derivative in measuring such rates. Now let's directly look at one question to understand this concept. A man 1.6-meter high walks at a rate 30 meter per minute away from a lamp which is 4 meter above the ground. How fast does the man's shadow lengthen? Now before proceeding this question, let's draw the diagram. So diagram looks like this. So this is our lamp, let's say AB, and this is point C. Let's say this is our man over here. Let's say D and E, and this is 1.6-meter high. Now ray of light is coming over here and that is why this particular shadow is forming EC. So EC is our shadow. Now as we know that if this particular person goes away, so this angle becomes more flattened out and this length EC becomes more longer, right? So basically we can say that as this distance is moving, as this distance is increasing, this distance is x, BE is x, x equals to BE. As this distance BE or x is increasing, the distance, the length of this EC, basically shadow, is also increasing. So we kind of know that x is dependent, directly dependent on EC. So we have this kind of idea, intuitive idea, not mathematical, intuitive idea. Now let's try to solve this. We know that we can form two similar triangles over here, ABC and DEC, right? So AB upon DE, that would be BC upon EC, right? This is the equation. Let's say EC equals to L. EC equals to L. Now AB is 4 and DE is 1.6. BC is X plus L and EC is also L. Now this is 4 into 10 divided by 16. That becomes 5 by 2 equals to X plus L by L, right? So 5L equals to 2X plus 2L. That gives us 2X equals to 3L. This is our equation. Now we can see that X and L are both related, linearly related. Now let's differentiate both of these with respect to time, with respect to t, that is so that we can use this particular speed. So that would give me 2 times dx by dt equals to 3 times dl by dt, right? Now dx by dt is nothing but 30 meter per minute. 2 into 30 equals to 3 times dl by dt. We have to find dl by dt only, right? We have to find how fast does this man's shadow lengthen. So basically we have to find out the rate at which this particular length is, this particular shadow is increasing. So that would give me dl by dt equals to 20, right? 20 meters per minute. That should be your answer. Now this was actually just one type of question. You can also get a question like this. Let's say you have one container and water is pumping in over here, and let's say at the moment water height is h and it's increasing with the speed of v meters per minute, right? This is increasing, this height is increasing with the rate of v meter per minute. Now what you have to do, you have to find out at what rate this volume is increasing, this volume of the tank is increasing. Right, so these are the kind of questions you can get. So what you have to do, you have to just find out the correlation. So volume and h, there is a correlation, right? and you can utilize that correlation to find out the derivatives of both sides and ultimately find out the rate of volume change. So basically these are the types of questions you can get in the examination. So until now, PGDB hasn't asked any question in this particular concept, but maybe they can ask questions in future. Now let us move towards the second application or derivative, that is tangents and normals. So first of all, let's define tangents and normals. Let's say this is a curve and we have a point over here. Now what we are doing, we are drawing a line that is just touching the curve at that particular point and nowhere else. So basically it's not intersecting it at 2 points, it's just touching at 1 point. So that line is called as tangent, and any line that is perpendicular it and passing through this point, that is also called, that is called normal, right? So this is how we define tangent and normal for a particular curve. Now we have two cases over here. Let's say we have a curve over here and we have a point over here. Now this point is actually on the curve and we have to find tangents and normal at this particular point on the curve, right? Now there can be another situation where we have this curve and the point is outside the curve, it's not on the curve, right? Now we have to drop normals and we have to drop tangents from external point on various points of the curve, right? So these are the two cases which we are going to see. So let's look at the first case, that is we have a point on the curve and we are trying to find out normals and tangents on that particular point. Now let's call this point as alpha comma beta. So basically the coordinates of the point are alpha comma beta. So the first step would be to find out the derivative. So that would give us m tangent. So basically slope of tangent. Derivative is nothing but slope of tangent, right? So that would be dy by dx. You have to differentiate and you will get the slope of tangent. Now yeah, you have the slope, you have the point, and you can write down the equation. So that would give us y minus beta equals to m tangent x minus alpha. That would be the slope of tangent. Similarly, we know that m1 m2 equals to minus 1 for the case of perpendicular lines. So basically if m tangent is the slope, so m normal would be minus 1 by m tangent. So this would be the slope of normal. And similarly you can find out the equation of normal. That would be y minus beta equals to minus 1 by m tangent multiplied by x minus alpha. This would be the equation of normal. Equation of normal, and this is for tangent, right? So this is the method in which you have to calculate the equations of normal and tangents. Now let's look at this question. Find the equation of the normal to the curve y equals to mod of x square minus x mod at x equals to minus 2. Now first of all, what we'll do over here, we'll try to open up the mods according to the given x point. So basically x equals to minus 2 and that is a negative point, so we'll open this mod accordingly. So that would give me x square minus this internal mod, this particular mod, that would open up as negative, and with this negative sign it will become positive. So that would give x square plus x inside the mod. Now we know that x equals to minus 2 over here and x square would be 4 and x would be minus 2. So internal of this mod is positive. So basically we can open up the mod as a positive sign with positive sign. So y equals to x square plus x for only x equals to minus 2 and not for any other point. Now let's try to find out the normal equation of the normal. So basically we have pi dash, that is m tangent, that would be 2x plus 1, right? And we have to just put the value minus 2 over here. That would give me 2 times minus 2 plus 1, that would be minus 3. Now m normal would be minus 1 by m tangent, that would be 1 by 3, right? Now you just have to find out the point. So x equals to minus 2, y equals to minus 2 square minus 2, that would give me 2. So basically we have got the point minus 2 comma 2. So equation would be y minus 2 equals to 1 by 3 times x minus minus 2, that would be 1 by 3 times x plus 2. So this is our equation, y minus 2 equals to 1 by 3 times x plus 2. This is the equation of normal. Now let us look at this example. Find the equation of the normal to y equals to x cube minus 3x, which is parallel to 2x plus 18y equals to 9. Now this is a slight variation of the standard format of question. So basically what they have done is they have given one more equation through which we can find out the point on the curve. So they have not given point directly on the curve, but they have given one information with the help of which we can find out the point. Now let's see how can we find the point. So basically, let's say this is our curve and we have to find a normal over here. So let's say this point is alpha comma beta, which we don't know yet, and we have to find out the normal over here. But what additional information they have given is they have given the equation of one more line, and we know m normal through here. So we know m normal through here. What we can do, we can apply this normal over here, and then we can find out the point. So let's see how it goes. Now let's try to find out the slope with the help of this equation. 2x plus 18y equals to 9. So over here, m normal would be minus 2 by 18. That would be minus 1 by 9. This is our m normal. Now let's try to differentiate. Basically, we'll be finding the m tangent and m normal from here. So m tangent would be basically y dash. That would be 3x square minus 3. That would give me 3 times x square minus 1. So this is our m tangent. So what would be m normal? M normal would be minus 1 by 3 times x square minus 1, right? And this should be equals to minus 1 by 9. So that would give us x square equals to 4 and x equals to plus minus 2. So we have got 1 point. We have got 2 points over here, x equals to plus minus 2. Now similarly, we can find out the points y. For y, let's take the case 1, x equals to 2. You can solve the other case. Let's consider the positive case. So y equals to 8 minus 3 times 2. So that would again give me y equals to 2, right? Now you have got the point. That is 2 comma 2. You have got the slope minus 1 by 9. Then you can easily find out the equation of normal. That would be y minus 2 equals to minus 1 by 9 x minus 2. This would be your equation for normal, right? So today's lecture was till here only, and we'll see the other part in the next lecture. And let's meet tomorrow. Thanks for watching.